Take a look at correlation for Leaving Cert ordinary level and higher level statistics. So the first thing we need to understand is what correlation is. So what I actually have is a heat map here of an example of correlation. The map on the left represents in blue the counties in the UK that voted for Brexit, and on the right the darker grey colours are where in 1992 the areas were affected by mad cow disease. So when looking at that map, you might be thinking there's some sort of connection, and that idea that we have in maths is called a correlation. So there appears to be some sort of correlation between voting for Brexit and mad cow disease appearing in that region in 1992. However, while correlation might exist, there may not be a causation. So that's something that's very important that we need to note as well. While we might be looking at a connection mathematically here, or a pattern in the numbers, it doesn't necessarily one causes the other. So that's where the phrase correlation, not necessarily causation, appears from. So very important that we understand that. We have no known mechanism for which mad cow disease might have caused people to vote for Brexit, but it's something that researchers might uncover later on. Here is one then that might be correlated and might have a source of causation as well. So this is the post-eclipse increase in eye pain Google searches. So here in the blue we have the light blue, we have the solar eclipse times when it was at its peak, and then in the pink we have people Googling that my eyes hurt after the solar eclipse. So there is a correlation there with the trends in the Google searches. There is also probably a causation there as well, especially looking at the regions in which these searches occurred. So this is again a heat map showing where these Google searches were happening on the left, and then we see in the right hand graph from NASA where the path of the solar eclipse was. So here we could say that there was a correlation and potentially a causation. So mathematically what a correlation is it's a statistical measure that expresses how related these two things are. So how linearly related for us in Leaving Cert. So we're going to look at as one increases what happens to the other, or as one decreases what happens to the other. Here's another graph that shows it in the linear form. So here is a breakdown of voters in the US versus their education level. So the more the percentage of voters for blue states, for example, there tends to be a higher number of the population that have a university degree or above, whereas red states appeared to have a lower level of education and as a result voted for Trump. So again, correlation there. Does it mean one caused the other? We'd have to investigate further, but we do see that there is some correlation between them. So the three main ideas you need to be aware of is that there's negative correlation, zero correlation, and positive correlation. So that's the three big ideas. Within that, then we can start to analyze it a bit more deeply. But first, a negative correlation happens when one variable increases. So say the temperature in Ireland increases. What might happen, what might decrease then is the number of people that are ordering hot coffees, or the number of people taking their coat in the morning. So that would go down as the number of the temperature increases. A zero correlation is when there's seemingly no pattern at all, or no linear pattern. examples of that, like the number of cats that people own, and I don't know, the hours of daylight. Like there might not be any connection between those two things. A positive correlation then would be as the temperature increases, the number of people wearing shorts increases. So as one increases, the other increases. So that's a positive correlation. Now, we need to be able to put numbers to these, and the numbers are fairly straightforward if you take a look at what's happening. No correlation has an R value, R being the symbol for correlation. It has an R value of 0, meaning there's no connection between the data at all. As you get more positively connected or correlated, we see that it goes from 0 to 0.5, and you can see the data starting to organize itself here. Then if it's a really tight line, we're looking at 0.8, and then if it's almost perfectly in a straight line, you will have a very, very strong correlation, which is 1. The lowest value that you can get is -1, and that is when it's perfectly negatively correlated. So 0's in the middle, no correlation. 1 is if it's perfectly correlated. 0.8 is around a strong positive correlation. If it's a weak positive correlation, so you're looking at 0.5 downwards, you're looking at a weak positive correlation. 0, no correlation. Minus, anytime you get a minus value, it's a negative correlation. So -5 then is, or -0.5 is going to be a weak negative correlation. -0.8 is a strong negative correlation. And then perfect correlation is going to be -1 then, perfect negative correlation. So what you need to remember is positive correlation results in positive numbers, negative correlation results in negative numbers, no correlation is 0. The closer you are to 1, the stronger it is. The closer you are to 0, the weaker it is. So let's take a look. This is an example of the 2024 exam paper question 7. So it says R is the correlation coefficient. So that's what we need to remember, is that R represents that link between them. And it says it's between the heart rate before exercise and the heart rate after exercise. Based on the diagram above, pick the value from the list that is closest to R. So give a reason for your answer. So this is negative and this is negative. But if I look at the data, my tip to you is to draw a loop around the data as best you can. And that's going in this direction, right? As I read from left to right, it's going up. That indicates to me that I am looking at a positive correlation. So that rules out these two. It rules out the -0.8 and the -0.2. So that leaves me with 0.3 and the 0.9. So if we think about what the difference between these two is we're going to be looking at, is it a weak correlation or is it a strong correlation? I would say that there is a strong correlation with the data here. It's not very spread out. It's not close to 0. So I would say that in this case, we're looking at a stronger correlation of 0.9. So the reason being, the data is showing us a line. So there is actually a straight line there. If you got your line of best fit and I got my ruler, you'd have a nice line there with ones that are not far off the data. And 0.3 would indicate that it would be very spread out, which it's not in this case. So your reason being, it's a positive correlation. Because as we read from left to right, as the heart rate increases, so does the heart rate after exercise. So heart rate before exercise is correlated to heart rate after exercise. As one increases, the other increases, and there is a strong linear pattern appearing in the data. Here's another one. So it's given us the cycle times and the run times for people performing. And it says the correlation coefficient between the times for these two events is one of the numbers below. Write the letter corresponding to the correct answer in the box. So is it very strongly correlated? In this case, if we take a look, it's actually much more spread out than the last time. So look at the difference between this graph where it's kind of nice and narrow versus this one where it is spread out and it's a bit wider. So I can't say that it is 0.95. I could potentially be looking at 0.77. I could be looking at 0.13. What I'm definitely not looking at is the negatives, because again, as I read from left to right, we're increasing. So as the cycle times increase, so does the run time. So I don't have D, E, or F in the running. Looking at B and C, this would be a very weak correlation. So I would be expecting the data to be much more spread out. I would be expecting more of a circular pattern. I would be expecting this to be much more spread out, a bit more all over the place. There is what appears to be a good line going through that. So I would say while it's not perfect, it's not very strong, it's quite strong. So I'd say it's 0.77. So I'd be writing B there. Now, the other thing you need to be able to do with this type of question, not only should you be able to match the graphs to the numbers, you need to be able to draw the scatter plots themselves. So that's mapping the data from a table of results. You also need to be able to get this correlation coefficient from your calculator. So make sure you know your calculator, how to use it, how to use stats mode for it. The easiest way to figure that out is to go to YouTube, type in the model of your calculator, and to bring up what you want, so the correlation coefficient. And there's dozens of YouTube tutorials that will show you specifically for your calculator how to get correlation coefficient. That's it for this video. So make sure you round off this topic by checking that you can draw a scatter graph, that you know how to draw a line of best fit, and that you know how to calculate the correlation coefficient as well as analyze it.